Hello everyone. Here's our video going over Quiz 1 Extra Practice, Math 1341, Calculus 1. This is for the biology sections. Well, looks like a lot. Really it is. These first four sections were our pre-calculus review. Section 3.1 is limits. Very nice. Number 1, write the domain of each function using interval notation. Well, here I have a denominator, and the second one, you notice I have a square root. So first, let's write what we need. We cannot divide by 0 in mathematics, so what I need is e to the x minus 1 not equal to 0. This would say e to the x not equal to 1. Well, you could take the natural log of both sides, but the only time e to the x equals 1 is at x equals 0. We can think about the graph of e to the x, for example. So here, this would say x cannot be 0. If you want to draw a number line here, perfectly fine. Here's 0, and we do not include, but everything else is okay. So in interval notation, we have minus infinity to 0, union 0 to infinity. This is my answer here. Letter B. Well, what's underneath the square root must be greater than or equal to 0. So we need this x times 5 minus x greater than or equal to 0. Let's jump into our number line. Here is 0, here is 5. So 0 is part of my domain, and 5 is part of my domain because we have this equals here. What I typically do at this point is we can pick something and test. So for instance, test -1, test 2, and test 6. At 2, we have 2 times 5 minus 2, 2 times 3, which is positive. So all of this is in my domain. At 6, we have 6 times -1, which is -6. That is not greater than or equal to 0. Not in my domain. At -1, I have -1, times 6, which is -6. Not greater than or equal to 0. And so my final answer is exactly this, what we're looking at. We have this closed interval, 0 to 5. This kind of question where we have inequalities, I think a number line can really help. Okay, number 2, we have a piecewise defined function that we want to evaluate, and then we also have some limits. Wonderful. Well, to evaluate f of minus pi over 2, that would be a negative number that is in this interval. So the formula that we use is sine of x. This would be sine minus pi over 2, which is -1. If we think about a unit circle, we are down here. Next one, f of 10. Well, 10 is definitely bigger than 1, so this would be, here we evaluate, we get 2 over 10, which is also 1 over 5. Letter B is about limits. Well, you notice 0 and 1 are what I call these breakpoints in my function definition. So in order to address the limit at 0 or the limit at 1 for my piecewise defined function, I need to look at one-sided limits. Let's take a limit as x approaches 0 on the left, f of x, and a limit as x approaches 0 on the right, f of x. And similarly, we will take a limit as x approaches 1 on the left, and a limit as x approaches 1 on the right. For these one-sided limits at 0, okay, the limit from the left, we use values less than 0, but approaching. We evaluate. So this would be the sine of 0, which is 0. Okay, the limit from the right, we use values bigger than 0, but approaching. So we evaluate here. This would be 2 to the 0, which is 1. Now, the limit from the left is not equal to the limit from the right. So at 0, the overall limit does not exist. At 1, for the limit from the left, we use values less than 1 and approaching. We evaluate here, 2 to the 1, which is 2. The limit from the right, we use values bigger than 1 and approaching. We evaluate here. We have 2 over 1, which is 2. Okay, in this case, the limit from the left equals the limit from the right. Therefore, the overall limit exists and equals this value. Next question. Solve for x. Give an exact answer. Okay, well, we have to do some properties of exponents. We will also need to use some logarithms here. First of all, the left-hand side, we have e to the minus 9x to the 1/3 power times e to the x. I'll just recopy the right-hand side. Now, power to a power, we multiply. So I have e to the minus 3x, e to the x equals 7. We have this product, and so we will add the exponents. We have e to the minus 2x equals 7. How fantastic is this? At this point, we have e to a single power equals 7. We can apply the natural log to both sides. So ln of e to the minus 2x equals ln of 7. The left-hand side is minus 2x, and then the right-hand side is ln 7. Finally, divide by negative 2. X is ln 7 over negative 2. This is an exact answer. If you typed it in your calculator and rounded, it would no longer be exact. Number 4, suppose the log base a of 5 equals capital M and the log base a of 3 is capital N. We want to evaluate this logarithm in terms of capital M and capital N. The log base a of 5a over 3. First, I see a quotient on the inside. So this becomes the log base a of 5a minus the log base a of 3. Really, I can think about one more step here. I have this product on the inside. So we have a product on the inside becomes this wonderful sum plus the log base a of a minus the log base a of 3. Log base a of 5, we are told it's m. The log base a of a, this is just 1. So plus 1, and then the log base a of 3 is n. Here's my final answer. We have m plus 1 minus n. I like this question. Number 5. Very nice. We have this piecewise defined function graphically. We want the limit from the left, limit from the right, overall limit, and function value all at 1. You can tell from our tick marks that this is -1. Okay, maybe that's all I need to solve the question. So the limit from the left, well, we come in from the left. We are approaching right here, y equals 0. Limit from the right, okay, we come in this way. We are approaching here, y equals -1. Well, the limit from the left does not equal the limit from the right, so the overall limit does not exist. Finally, the function value. This is where it's filled in, right here. So f of 1 equals -1. Number 6, find the reference angle and quadrant of the terminal side for theta equals 8 pi over 3. Well, here is a unit circle to help us think. Now, all the way around the circle is 2 pi, which is 6 pi over 3. 6 pi over 3 gets us to here. We need 2 more pi over 3, but that is not acute. That would not be a reference angle. So if we move 2 pi over 3, we are here. So we can answer the first part of the question. The terminal side is in quadrant 2, but let's think further about this. Note that I can write 8 pi over 3 as 9 pi over 3 minus pi over 3. Pi over 3 is acute, so that would be here. Okay, now we see our reference angle. The reference angle is pi over 3. The reference angle is always the acute angle made by the terminal side and the x-axis. In this case, it's right here, pi over 3. Wonderful. Number 4, suppose theta is in quadrant 2 and the sine of theta is 5 over 13. Find the cosine of theta. We get to use this most important trig identity, which is really the only trig identity that I care for you to memorize. Sine squared plus cosine squared is 1. Okay, very nice. So here's my unit circle. We are told theta is in quadrant 2. Note that the cosine is negative here. Well, we use that sine squared plus cosine squared equals 1. Sine is 5 over 13. We get the cosine squared, theta equals 1 minus, well, this number we get 25 over 169. 25 over 169. Let's see, this is 169 minus 25 over 169, which is 144 over 169. This is the square of the cosine, but we are in quadrant 2 where the cosine is negative. Let me make this all slightly smaller. Cosine theta is negative the square root of this. In this case, we get minus 12 over 13. Okay. Number 8, we have 3 limits. So first of all, at least for A and B, let's try to evaluate. Okay. Here, we evaluate at 3. I get 9 plus 6 minus 15 divided by 9 minus 9. Well, you notice this is 0 over 0. What does this mean? Most importantly, it doesn't mean we just write d and move on. The 0 over 0 tells us to do something. This is an indeterminate form. Now, in this case, we can factor the numerator and factor the denominator. So we have a limit as t approaches 3. My denominator might be a little easier to factor. This is a difference of squares. So I have t minus 3 and t plus 3. For my numerator, okay, we should have a t minus 3 as one of the factors. That's what's giving us this 0 over 0. The other one, oh, plus 5. T plus 5. We can check. If you multiply these two, we get negative 15. Add them, we get positive 2. So we have factored correctly. Now, we can take a limit as t goes to 3. we have t plus 5 divided by t plus 3. This is beautiful because what's left, we can just evaluate at t equals 3. We get 8 over 6. Simplified, this is 4 over 3. Next one. Once again, our strategy, we try to evaluate. Okay, what happens here? Well, we get the cosine of pi divided by 1 plus 8. But you notice I don't have anything indeterminate. The cosine of pi is -1. So I just get -1 over 9. This is my limit. Last one, we have a limit at infinity. So what do we want to do in these type of questions? Well, when we have polynomial divided by polynomial, which is called a rational function, we want to divide every term we see by x to the highest power. Okay, in this case, it's x cubed. So let's do this. We have a limit as x approaches infinity, 2 over x cubed minus x cubed over x cubed divided by x squared over x cubed plus 3x cubed over x cubed. Okay, we have a limit as x approaches infinity. This first term is already simplified. We have 2 over x cubed. The second term here, this is -1. Then this one is 1 over x, and this one is plus 3. So let's write that. Now we can use properties of limits. So 2 over x cubed as x grows without bound. This goes to 0. Next one. 1 over x as x grows without bound. This also goes to 0. So I'm left with -1 over 3. This is my limit. Now all 3 of these limits existed. How wonderful is that? Okay, this was so much work and at the same time so much fun. This is the end of our quiz 1 extra practice. Thank you so much.